The target is the ocean liner SS Egypt. Operating off the coast of France in a dense, blinding fog bank, the vessel encounters an intersecting course that dictates an immediate and catastrophic structural failure. The approaching ship is the French steamer Seine. Seine is no ordinary merchant hull. Its ice-strengthened bow is built to absorb punishment, so in the fog it becomes a rigid wedge. When the ships collide blind, that hardened prow drives into the port side of the SS Egypt, tearing deep into the liner in a way no swell or wind could reproduce. Deep inside the lower decks of the ocean liner sits a fortified strongroom. This vault contains a high-density cargo of heavy precious metals, gold and silver bullion alongside thousands of gold sovereign coins. Contemporary accounts and insurance estimates place the total value at over £1 million. It represents a massive concentration of extreme wealth locked securely within the complex steel framing of a major transport vessel. The ship is rated at 7,941 gross register tons, a measure of internal volume, not weight, a vast steel liner built for scheduled open water passages and the immense cyclical stresses of the ocean. Built to carry distributed wind and wave loads along the hull, the liner is not designed for a perpendicular point load driven straight into its side, and Seine delivers exactly that. Most of the steamer's momentum concentrates into a small patch of side plating. The ice-strengthened bow refuses to crumple, so it cuts in, slicing the outer skin, breaking ribs and decks, and ripping apart longitudinal supports. This deep penetration shatters the watertight integrity of the SS Egypt. Large ships depend on transverse bulkheads and watertight doors to confine flooding. But in the chaos after impact, that system cannot contain what surges in. Water races through damaged spaces, spreads beyond where it should have been stopped, and the ship begins to lose the fight for buoyancy. The bullion in the strongroom is too dense to float or scatter. It stays where it is as the ship starts to go. Flooding shifts the liner's center of gravity and wipes out reserve buoyancy faster than pumps or damage control measures can answer, accelerating the sink. The entire destruction sequence, from the initial deafening impact to the final loss of surface stability, spans about 20 minutes. At 20 minutes is a violently compressed window for a structure of this immense volume. It means the incoming water is not merely leaking, it is surging through the main internal arteries of the ship, rapidly displacing massive volumes of breathable air and crushing secondary bulkheads before they can even be secured. The internal flooding creates an asymmetrical weight distribution that pulls the ship forcefully onto its side. SS Egypt begins its terminal roll. The ship shudders under the shifting, dynamic weight of thousands of tons of incoming ocean water. The massive ship slips violently beneath the surface of the sea, dragging its fortified vault and the 1 million pounds of isolated wealth downward. The vessel descends rapidly, dropping through the deep water column, the ruptured structural steel, the internal debris, and the locked strongroom eventually slam into the seabed floor. The wreck settles at a reported depth of 420 to 430 feet, roughly 70 fathoms. Deep enough that traditional diver-led recovery is no longer realistic with 1920s equipment. At that line in the water column, hydrostatic pressure becomes the hard boundary that defines what a human can do. To bypass these severe limitations, the Italian salvage company arrives with a mechanical countermeasure. They bring Neufeld and Cuenca-style armored technology. Early atmospheric equipment intended to keep a diver at near-surface pressure even as the sea tries to crush everything else flat. This machine represents a massive escalation in marine engineering. It is not a flexible protective dress, but rather a rigid, heavily cast steel casing designed to completely encapsulate the human operator. The primary functional goal of the thick metal shell is to isolate the human biology entirely from the crushing hydrostatic forces. Inside the heavy steel torso, the internal atmosphere remains carefully regulated at a normal surface pressure. The human lungs do not face the dense toxicity of compressed deep water gases. Salvage operations require aggressive mechanical intervention, not merely survival. To interact with the ruined hull and the trapped vault, the Neufeld and Cuenca design features heavily articulated, segmented metal arms and legs. These limbs connect directly to the main rigid torso through a complex series of specialized, interlocking ball and socket joints. On the dry deck of the salvage ship, These smoothly machined metal bearings glide effortlessly against one another. This allows the heavy metal limbs a wide degree of flexibility and a functional working reach. The internal operator can successfully pivot, bend, and theoretically grasp heavy rigging cables. The rapid descent into the dark ocean radically alters this mechanical equation. As the heavy steel unit drops vertically through the water column, the surrounding ambient pressure multiplies significantly. At 400 feet down, the strict physics of the environment mount a relentless mechanical assault against the articulated armor. The massive physical weight of the surrounding ocean actively pushes inward from all directions, seeking to violently collapse the empty pocket of surface air trapped safely inside the hollow torso. This severe external force bears down directly upon the critical ball and socket mechanisms connecting the external arms and legs. At depth, that pressure tightens tolerances until the joints move reluctantly, or not at all, and meaningful work on wreckage becomes unreliable. At depth, the suit seizes, the articulated limbs lock rigid, leaving the operator able to see the wreck but unable to grab, pull, or rig. The shell keeps the pressure out, yet it turns the diver into a spectator. The salvage team now has to dismantle the wreck without the use of hands. The failure of articulated mobility forces a hard redesign of the salvage methodology. Chief diver Alberto Gianni recognizes that fighting deep pressure with complex external joints is a losing equation with the metallurgy of the era. Instead of chasing deep water dexterity, he pivots to a simpler idea, a rigid observation chamber of the torretta butoscopica, built to survive the depth and let a human see, judge, and direct. This new apparatus is a sheer steel cylinder with thick glass viewing ports, built with no moving external parts. With the joints eliminated, the deep pressure has nothing to seize. It bears harmlessly against a smooth, continuous shell. Sealed inside, the diver becomes a protected observer, an eye and a processing brain, while the salvage ship on the surface supplies the working hands. This massive physical disconnect requires a flawlessly synchronized line of continuous communication. A heavy armored telephone cable connects the isolated observer in the deep steel cylinder directly to the winch and crane operators working high above in the fresh air. To breach the ruined ocean liner, the team adopts a terrifying and highly precise industrial method. They initiate a strict sequence of telephone-directed explosive demolition. The primary target is buried deep inside the armored structural framework of the wrecked ship. To reach the trapped vault, the salvage team must systematically and violently dismantle several steel decks. The heavy surface cranes hoist large concentrated charges of high explosives over the side of the ship. The lethal payload drops rapidly down the long vertical line toward the dark wreckage below. The isolated diver suspended inside the torretta butoscopica watches the explosives descend through the limited visibility of the deep water. Hovering dangerously close to the impact zone, the diver transmits continuous real-time course corrections. He speaks directly into the microphone, verbally guiding the massive suspended explosives through the jagged structural debris and precisely onto the required target coordinates. Placing explosive charges against thick steel demands careful positioning. Not a crude guess, but controlled placement guided by the observer below. When the charge is set where it needs to be, the observation chamber is moved back to a safer standoff, and the crew fires the blast. The resulting underwater blast generates a massive concussive shockwave that shatters the targeted steel plates instantly. The sheer density of the water actively magnifies the localized destructive force of the explosion against the ship hull. Following the violent detonation, the divers lowered slowly back down into the dark ocean to survey the fresh destruction and calculate the coordinates for the next explosive drop. They repeat the sequence, driving deeper with each blast. They successfully shear through the thick upper layers, violently removing all 4 steel decks piece by piece. The aggressive explosive path finally exposes the heavy reinforced bullion room directly to the open ocean environment. The heavy prize is finally visible from the glass ports of the steel cylinder. But the weather window closes. Winter surface conditions drive the salvage ship off the deep water station and into a secondary winter clearing contract, the shallow wreck of a wartime munitions transport vessel named the Florence 8, close enough to the surface to be a navigational hazard and requiring demolition. The operational profile for this secondary target differs completely from the deep ocean extraction. The shattered transport ship still contains a massive, unexploded military cargo securely trapped within its flooded internal holds. Exactly 150 tons of high explosives sit submerged inside the deteriorating steel framework. To eliminate the navigational hazard, the salvage team plans to lower a sequence of small, highly controlled clearing charges directly onto the projecting steel superstructure. The goal is simply to flatten the highest wreckage, not to obliterate the entire hull. The plan leans on a tempting assumption that 12 years in corrosive seawater since the First World War has killed the danger. Acting on that belief, the salvage vessel holds station nearby at a standoff distance that proves catastrophically insufficient, then lowers a small clearing charge onto the projecting steel and fires it from the surface. The localized underwater blast generates a sharp, highly concentrated concussive wave designed to cut the upper steel. However, instead of safely dissipating through an inert and dead cargo, this high-velocity shockwave travels directly into the flooded lower holds. The intense kinetic strike violently hits the chemical matrix of the submerged military munitions. The extreme concussive energy instantly restrikes the molecular bonds, proving the military-grade compounds are still completely viable. The localized blast forces a massive, unstoppable sympathetic detonation across the entire buried payload. But all 150 tons detonates inside the confined steel hull at once, releasing a catastrophic outward blast wave. In shallow water, the force cannot bleed off into a deep column. It follows the path of least resistance and erupts violently upward toward the surface. A colossal column of violently displaced ocean water, superheated expanding gas, and shredded, jagged steel debris blasts directly upward. This massive kinetic transfer instantly and completely engulfs the heavy salvage vessel holding station immediately above the blast epicenter. The sheer physical force of the upward shockwave completely overmatches the structural integrity of the salvage ship. The immense energy violently lifts, shatters, and tears apart the heavy steel surface vessel in a fraction of a second. The catastrophic explosion instantly kills the chief diver and completely destroys the highly specialized core engineering team. The operational brain trust of the salvage company is violently erased. The primary ship is annihilated, leaving a totally severed salvage chain and an unprotected, open vault sitting alone in the deep water miles away. With the core engineering team gone, the salvage company director faces a massive operational trade-off. He must either permanently abandon an exposed vault containing a massive fortune to the dark ocean, or immediately finance and equip a secondary heavy expedition to attempt a highly unpredictable mechanical extraction. The director chooses the financial risk and rapidly commissions a replacement surface vessel designated the Artiglio II. A completely new heavy engineering crew deploys back out to the deep water coordinates. By the time they return and begin pushing the work forward again, nearly a decade has passed since the SS Egypt went down. The destructive explosive phase is largely finished, replaced now by an aggressive phase of pure mechanical extraction. To retrieve the heavy precious metals from the deep ruin, the new engineering crew utilizes heavy industrial steel clamshell grabs. These massive mechanical jaws are suspended directly from the long, vertical cables of the surface cranes. Because the internal observation diver cannot physically reach out to guide the heavy tool into position, the extraction process relies entirely upon gravity, momentum, and sheer mechanical crushing force. The diver suspended inside the smooth steel cylinder simply calls out the exact spatial coordinates over the heavy telephone line, directing the massive shadow of the tool from a safe distance. Operating a heavy mechanical grab at the end of a long vertical line requires intense coordination to defeat the natural sway and drift caused by the deep ocean currents. The long steel cable acts as a massive pendulum swinging in the unseen water column. Once the surface cranes perfectly align the heavy mechanical grab directly over the verified target coordinates, the winch operators completely release the heavy braking mechanisms. The massive steel clamshell freefalls rapidly downward through the final vertical stretch of the dark water column. It plunges brutally into the violently shattered steel of the open bullion room. The immense downward momentum of the heavy physical impact drives the open metal jaws deep into the dense layer of structural wreckage, torn steel decking, and completely loose cargo resting at the bottom. The surface crew immediately engages the massive heavy steam winches to forcefully reverse the kinetic direction. The intense upward tension applied to the primary pulling cable instantly and forcefully snaps the thick, heavy steel jaws completely shut. As the heavy mechanical jaws violently close upon themselves, they indiscriminately bite out a massive, unrefined physical cross-section of the ruined compartment. The heavy surface cranes haul the fully loaded grab straight up through the long vertical water column. The huge steel jaws finally break the ocean surface and aggressively dump the recovered payload directly onto the thick wooden deck of the Artiglio II. Initially, the heavy blind grabs retrieve only massive loads of crushed structural steel, rotted wooden planking, and utterly worthless internal ship debris created by the earlier explosive blasts. The surface crew meticulously sorts through the wet, jagged wreckage, manually separating the ruined ship components from any trace of the target cargo zone. This highly repetitive, heavy industrial mechanical cycle of blind dropping, violent biting, and heavy upward hoisting continues relentlessly above the deep water wreck site. The heavy mechanical jaws violently clear away the final layers of fragmented steel and bite deeper into the absolute structural floor of the completely exposed vault. Finally, in June 1932, the heavy clamshell grab crashes down into the concentrated heart of the cargo. The thick metal jaws lock shut around dense, unforgiving weight. The heavy mechanical tool breaks the surface and dumps the wet load onto the ship's deck, reportedly delivering the first recovered gold bullion from the wreck. The massive blind grabs hit their mark repeatedly in the deep, dark water, leaving only the final mathematical tally to define the ultimate historical outcome of the completely unprecedented salvage mission. The physics of violently shredding a heavy marine structure fundamentally transforms a complex three-dimensional maze into a flat, two-dimensional extraction grid. By completely obliterating the heavy overhead architecture, extreme industrial destruction nullifies the primary structural defense of a targeted shipwreck. This brutal process converts a deeply buried internal space into a wide-open deep ocean pit, granting heavy surface machinery absolute vertical dominance over the target zone. Now the work becomes purely vertical. The heavy mechanical clamshell grab possesses absolutely zero biological finesse. It does not delicately sort or visually select individual heavy metal components, resting in the darkness at the bottom of the sea. Instead, the massive steel jaws forcefully bite deep into the completely compacted floor of the structural ruin. The heavy metal teeth aggressively scoop up raw, deep ocean mud, shattered internal steel framing, and tightly clustered heavy precious metals all simultaneously in one massive, undifferentiated load. The surface vessel must execute relentless micro-adjustments to its exact physical position using a complex array of heavy mooring cables. By shifting the entire floating ship by mere feet upon the turbulent ocean surface, the crew precisely alters the downward trajectory of the suspended heavy mechanical tools. This extremely precise surface maneuvering allows the heavy grabbing jaws to methodically scrape across every individual square inch of the exposed internal decking. The exceptionally dense heavy metals naturally settle heavily into the lowest available physical crevices of the violently shattered steel structure. The relentless heavy downward bites forcefully tear away these final structural floor plates, ensuring absolutely no deep, localized pockets of valuable cargo remain hidden securely beneath the layered wreckage. On deck, and the crew sorts each wet load by hand, stripping value from wreckage. Recovering a prize of that density and scale requires thousands of perfectly executed vertical lifting cycles. The massive physical tonnage of the recovered bullion demands a continuous, heavy expenditure of mechanical power from the surface ship. By the year 1935, this relentless heavy mechanical cycle finally exhausts the targeted deep water zone. The rigorous accounting that follows points to an extraordinary result, not a perfect total, but the vast majority of the treasure recovered. Depending on how different sources counted bullion and coins, the figure is often cited in the mid-90% range, sometimes rising toward 98%. That near-total recovery validates the method. Keep the human as a protected observer in the smooth steel bell and let surface machinery do the heavy work. The massive concentration of gold and silver bullion, once violently dragged completely into the deep, lethal ocean column, is meticulously cataloged and fully restored to the global financial ledger. The absolute mechanical efficiency of the highly crude industrial process completely overwhelms the extreme deep ocean environment. The crushing hydrostatic pressure remains permanently lethal to the fragile human biological system. However, the relentless and precise application of raw, downward kinetic force violently compels the sea to completely surrender the deeply trapped fortune.